This talk will be about OpenTelemetry and how we use it in Hostaway, the company that I work for. So that's the agenda, and that's a short information about me. As it was said, I'm over 20 years with PHP, and I really like OpenTelemetry, and I love working with performance optimization and all that stuff. And I am OpenTelemetry contributor. Some of my patches are already in, and I'm working on some new stuff. Hopefully, it will be soon also in. Before we start, there will be some code samples, and there is a Docker Compose with everything compiled into one. It will be available at this link. It is there now, but of course, I worked on the presentation 10 minutes ago, and it's still not updated yet there, but after the presentation, I will push everything. And I will update this repository when I add some new stuff. I will also show the QR code at the end of the presentation. This talk is focusing only on backend PHP code. OpenTelemetry can be used for many things. Can be used for frontend, can be used for backend, but in this talk we will for backend in other languages, but in this talk we will focus on PHP backend code. So, quick survey. Did you know OpenTelemetry before this talk? Okay. Who's using it right now? Okay. Who's using something else, some other APM like New Relic or Datadog or? Okay, so the topic of observability should be known to you guys. So, not sure why you're here. So, I think I can briefly discuss the observability, but it's the more complex application became, the harder it become to observe them. When we have 20 microservices, 10 of them in PHP, 5 of them in Node, 2 of them in Python, there is a need to combine all the information about the performance of the whole thing, and to get information where there are bottlenecks. How you can find out what's going on inside your application and how you can fix them. So OpenTelemetry is an observability framework. It was created by Cloud Native Computing Foundation, that is a part of the Linux Foundation. It is a merge of OpenTracing and OpenCensus that was donated and combined together by Google to create OpenTelemetry. It is a vendor-agnostic framework that defines the way that you can observe your system. What is it not? It's not free, as in a beer, because it requires developer time, it requires DevOps time, it requires servers, it requires storage. So in this case, it's not free. It's not simple, because it does require some setup, it does require deployment, it does require maintenance, but it is not that hard to start. And it is not for everyone. If you are smaller on scale, then you should probably use either some existing APM solution, like all in one, like New Relic or Sentry or something like that. And I think this can be measured in the terms of how many paid users your SaaS have. If you have more servers than paid users, then probably OpenTelemetry is not for you. So why should you use OpenTelemetry? First of all, it's vendor agnostic. It's stack agnostic, framework agnostic, language agnostic. You can use one set of tools to instrument the whole application. It is used by industry leaders, and did I mention it's vendor agnostic? So why did we decided in Hostaway to use OpenTelemetry? Our application is written in somewhat obscure framework, Falcon. I see that is smiling. It's written in a rather obscure framework, and none of the vendors for existing APMs were providing auto-instrumentation for that out of the box. So we would have to instrument it manually anyway. So we decided that we will use OpenTelemetry because we then could start writing telemetry instrumentation in the code before we choose the vendor for the data. So the basics. What do we get when we use OpenTelemetry? Let me show you. So this is the repository that I mentioned before. It has two Symfony applications and one Laravel application, and some tools installed. Laravel, I found like a demo e-commerce shop, so it's a simple one. And for the demo, I think this is official demo from Symfony. Why two? Because one of them is configured a bit differently. So in terms of tools, we have a tool called Zipkin. It's one of the first tools that was introduced with OpenTelemetry, and it's focusing on showing you the traces and spans in your application. It is useful because it's small and can be used for for example, on a local machine. The same goes for Jaeger. Actually, before we start, let me get some data in. The same goes for Jaeger. It's a bit more complex, but it's also a simple tool focusing mostly on displaying traces and spans. It has a neat feature of comparing them. So we can select multiple and compare them. Those are two different, so it's showing a lot of red, but you know what, you can imagine what it be like. And some other tools. For example, OpenSearch and Elasticsearch natively support OpenTelemetry data. Prometheus reads the metrics. Grafana reads the metrics. And tools like Uptrace, which is a similar tool to New Relic or Datadog, but you can self-host it. So that's why I have it here. So in the rest of the talk, I will be focusing on Jaeger and Uptrace. So let me actually select one. So in this view, this is a pure Symfony application. I haven't done any changes other than installing the OpenTelemetry auto instrumentation packages. And out of the box, we get Symfony instrumentation. We get stuff like routing, root detection. We get I/O instrumentation. We get cache. In this case, this is the PSR6 instrumentation. We get PDO with the query that is being run. So everything is out of the box in this view. So let's continue. So as you saw, OpenTelemetry allows us to collect logs, to collect metrics, collect traces and spans, transform them using the OpenTelemetry collector, adding or removing some attributes, filtering the spans, or dropping them. And it says nothing about presenting the data. It doesn't even say anything about storing the data, except for the metrics, but that will be in the next slides. So basically, it's just a framework of getting the data and sending the data. The source can be anything we want. It can be application, it can be host, it can be a container, pod, a hardware device, a server itself can be also instrumented. Anything we want. The instrumentation data is referred as a signal. It describes an activity in the system. It can be a log, it can be a metric, it can be a trace that contains a span. And to all of those signals, we can attach metadata in form of a baggage. The signals are saved in the scope of a context. The context is trace ID and the whole trace metadata. It can be a web request, it can be a worker execution, it can be a message processing queue, it can be whatever we want. For example, a physical signal like something happening in the real world even. It allows us to correlate multiple signals into one information. The trace is a set of spans that records one thing that happened. It can contain data from multiple services, and this is important because when we have a web request, it enters our application, and then, for example, we execute some calls to external APIs. Those are all in scope of one trace. So if the user presses order now button, we execute multiple things, but this one order creation is one trace. It's often represented like this in the tools that I showed you. Please note that, for example, the yellow ones are external calls, for example. Actually, everything starting with slash is external call. So as you can see, it combines the data from multiple services. One span is one unit of work, but it doesn't have to be like one-to-one matching to like a database call or file opening. It can be around your whole method. So one thing happening. It can contain status of the operation, real-time data, metadata, link to other spans, and can contain events, like, for example, logs. The span metadata is a standard key value store, but there is one thing that I strongly recommend. Instead of using keys that you think about, use the keys that are described in the OpenTelemetry documentation. It helps a lot, especially if you're using some out-of-the-box tools like New Relic or something else, because they expect some data in the attributes. Like an example, if you put HTTP root on your whole trace, then it will group them, multiple traces, will group them by the root. So it's easier to see what's going on. But if you use your own attribute, then there is no mapping. So you lose a lot of things. This is an example of span attributes for web request. As you can see, the root doesn't contain an actual ID, and that's why it's easier for some tools to aggregate the data. Metric. So metric, it's like a smaller thing than the trace. It contains only one information, it contains a value, and also it contains a metadata. And a metric should be the main tool for you to measure the performance. I know that the spans and traces look the best if you looked at them in the tool, but metrics should be the main focus of your observability stack. And I just explain why in a bit. So once we decided to use OpenTelemetry, how do we actually do it? So first we need to send the data somewhere. OpenTelemetry provides a tool called OpenTelemetry Collector, and it's a proxy between your application and the backend for your data. It's vendor agnostic, so you can use the same collector to send the data to multiple targets. You can even have one collector installed and dynamically decide where to send the data. There are two main ways of deploying the collector. One is called agent deployment. So you have a server, you install the agent, and then you configure it and it sends the data to the server, so to the backend. One server, one agent. It offers lower latency, but it's a bit harder to maintain. If you have 50 hosts, you need to have a strategy to send the config updates, for example, monitor the agents, and stuff like that. For bigger deployments, you can get collectors on a separate machines and expose them behind, for example, Nginx load balancer to have centralized place to manage them, but this will give you higher network delay. Collector is actually optional. If your backend natively accepts OpenTelemetry data, you can send data directly to them. But if there are any issue on the backend, then it will break your app. So the backend is basically a storage. You can have different backends for different types of signals. As an example, before I showed you Jaeger, and Jaeger focuses only on traces. So it doesn't accept either metrics or logs. The same goes for Zipkin, but Uptrace on the one endpoint accept any type of signal. Some only store data and require a separate UI. Some are all in the one, offered as a SaaS. And examples can be OpenSearch, Jaeger, Uptrace, New Relic Sentry, and many, many more. The UI is built on top of your backend that you choose, and it can be used to visualize the data. There is a lot of different backends. Some of them are offered as SaaS, some of them you can self-host. Yeah. So, instrumenting the code. You can either do it manually using SDK. There are methods for everything. There is no black magic there. You just call the method and that's it. Or you can use auto-instrumentation that is offered by OpenTelemetry repository. And they offer an extension to PHP, which has some great cool features that I will show you in a sec. You can also instrument the host itself. The agent, the collector can read the log files from the host, can interpret them, transform them, and send them to the backend. And you can, of course, collect metrics and logs. So, auto-instrumentation will give you this is like a set of extension and SDK and libraries from OpenTelemetry. It will automatically create UTRIs, and it will automatically create spans for given operations. For example, there is a cache auto-instrumentation, and it will create a span for every read from the cache. It will attach the key to that read. It will attach the start of the read, end of the read, so you can combine that and get some statistics. Unfortunately, not a lot of auto-instrumentation libraries from OpenTelemetry contains metrics. For now, they are focusing only on spans, and I'm actually working on some metrics focusing only code for that. There is also an extension that I mentioned before. It's PHP 8 only 8+ extension. It gives you a hook function that I will show you in a sec, and it helps you a lot. You don't have to use it. You can rely, for example, on a framework events to get the before and after, but the hook function helps a lot. Okay, let me show you how it works. Is it visible? Okay. So we have a hook function that accepts object to hook and a function. When you use it for functions, you of course provide a null for an object. And two callbacks, the pre and post. Those are simple PHP functions with specific parameters that you can do anything you want in them. So I have two examples of a simple hook usage. It's printing before and after, and then before to and after to. Because you can hook the same function multiple times. It doesn't have to be all in one. And now this is the test function, and this is the call for the test function. When I run it, you will see 1, 2, function execution, and matching 2, and then matching 1. You might be wondering why we pass 1 and get 3, because hook allows you to modify the parameters. So we can change them, we can read them, we can use them for many things, and use that for instrumentation or metrics collection. So in this example, it's one of the best features because it allows you to hook an interface. So any object implementing this interface will automatically have this method hooked. In this case, we have before, we also changing a parameter, and we have an after. This is the interface, this is the class that implements it, and the function body. So now when we run it, you will see that before was executed, and we have the object that was passed here was an actual instance of the object that we hooked, not the interface. So we have before, we have then some method, we are throwing an exception in this method, and then we have an after that is getting this exception instance. So we know when the execution of the code failed for any reason, for example, bad syntax or query error or anything. So we can use that information to record the fact that this query failed. Okay, so this is for instrumentation. So, metrics. It can be both on the infrastructure level or a business logic level. If you want to store information, how many orders you have, how many users are registered, how many sessions are active, those are business level metrics. If you want to store the information, get the information, how many queries you run, how long it takes to run a query, this is infrastructure level. So you can capture everything. It can have unit, it can have metadata. There are different types of metrics that I will describe in a sec. But again, this should be a main type of signal that your application sends. So those are the types of metrics. And I know that some of you might be thinking that it was supposed to be simple, and I see some asynchronous counter, gouge, or whatever. But this is really simple. We divide metrics into two types, synchronous and asynchronous. And the synchronous ones are the ones that are in the request. So they can be connected to a context. And asynchronous ones are the ones that are out of context. An example might be, for example, might be that we want to have a number of items in a queue. It is a state of the system. It's not related to any particular user. It's just the information how many items we have in a queue. So synchronous metrics are used for, the basic ones are counter and up-down counter. The counter always goes up. If it's like a global state of how many users registered. Even if the user deletes the account, it was still a registered users, so it always goes up. The up-down counter is a counter when you can send +1, +5, +10, or -1, -5, or -10. And this is a counter that shows you the current state of the thing that you are trying to count. For example, number of active sessions, number of DB connection. And the up-down counter is super useful with the hook function that I showed you. Because at the beginning of the database call, you can send +1. And when you end the database call, you can send -1. And then if you load the UI in this given moment, you will get the current number of queries. Not the total, but for example, current. So, sorry, this is the wrong title. This is still synchronous metrics. If you want to record a duration of something, then you use a histogram. For example, how long it took for a query to execute, how long it took to API call. If you want to send the current value of something, then you use gauge. For example, CPU usage, you don't add it in time, so it's not a counter like +1. It's like currently it's 7. So for asynchronous metrics, as I said before, those are not related to context. Those are the system state. That's why you have an asynchronous gauge, asynchronous counter, and asynchronous up and down counter. So the main thing when you decide about the metric type is the context. If it requires a context, if it requires a user ID, controller, action, root, anything, then you use synchronous. If it doesn't require that, you use asynchronous. So why metrics are that important? This is a lesson that we actually learned in Hostaway, because when we started our proof of concept deployment with one of the providers, one of the vendors for OpenTelemetry data, OpenTelemetry backend, we instrumented everything. We enabled everything that was possible to enable. We deployed it on the production, and it was great. No one noticed any bottlenecks in the performance because of the way that collector is written. So you just, from your application, sends the data to the collector, and then it sends it further into the backend. So it's really, really fast. But the problem was that we were dropping data. We couldn't figure out what's going on. The UI was showing orphaned spans, orphaned traces, and we couldn't figure out what's going on. So after a few days, the vendor engineer that we were speaking to said to us, guys, you know that you are sending us 20 million spans a minute, and our limit is 6 million spans a minute. So that's why you're losing data. And that's why metrics are more important than spans and traces, because a trace can contain 100, 200, 500,000 spans, and each span contains metadata, contains the information about the host, so it produces a lot of information. And then when you self-host it, then you need to store it, you need to process that, you need to pay with the compute, basically. And if you use external provider, then you need to pay for the compute, for storage, and for everything. So it's important to send metrics instead of spans and traces. Even if you send only spans and traces, you will see some information computed by the vendor or the tool that you use, like throughput or error rate, but this will require all the data. And if you start losing that, or if you start sampling, then you will get less information. Additional parameters on metrics. So there was the asterisk before. So each metric can have a unit. This can be a millisecond, second. This can be kilobytes. This can be something else. A description. And some UI tools are using that description to display it on a page. And it can contain advisory. So there is no way for your code to say exactly that this should be below 100 millisecond. Your code can say it, but the tools are not parsing that information in any way. So they will not create you an alert. But if you have a bigger team and separate people are working on instrumentation and the separate people are working on infrastructure and alerts, a simple information that this should be below 100 millisecond is priceless, because they can just open the dashboard and create alerts automatically, basically. Okay, let me show you some stuff about metrics. Oh, I missed something about traces. So let's get back to the traces first. So here we have a simple code that uses one of the installed Symfony instances. And first, I'm showing you the manual way. In a sec, I will show you the automatic way. So we create instrumentation. We create a root span. This is the difference. Basically, the trace, we create a trace. Trace and the span differ only in this. It's server or internal. We are starting the span, we are storing it in context, and we are storing it in the context. So one note, the OpenTelemetry SDK and API uses a lot of globals and a lot of state. And at the beginning, I was a bit skeptical about that, but the longer you think about it, the more sense it makes, because each span is totally independent of any other spans. So you can create spans in the middle of your code, and it still needs to know the parent. It still needs to know the current context, the attributes, and everything. So that's why they use a lot of globals and a lot of state. You can also create spans using attributes. In this case, we have around a method. And then we want to promote some of the arguments to be attributes on that span. We call it, and then we end. So this is a debug only, so you don't have to have it. But if I run it now, you will see how much data it generates about one operation, basically. But in this data, you will get attributes, and you will get the attributes from the call. So basically, this can be handled automatically at the beginning of your code. And then it's just a matter of adding, for example, attributes. You don't have to do any other manual work. This is a simpler example without the classes. So it creates the same span. This is the same code. It's doing some stuff, and it's ending. And this is a block controller from the example Symfony application. And the only change that I did in it is this. And I'm calling the second Symfony from the first one. So if we switch to cannot find it, one sec, Symfony. Okay. Now we can go to the metrics. So let's imagine that we have some function, and we want to know how long it takes to, when we start, how many times we call it, how many we have active right now, and how long it took for us to run the function. So as you can see, we define the metrics manually, and we will get them in the other on the backend. But we can also use the hook that I showed you before. So we have the same function as before, but note that there is no metric information in here. We hook it by name, and then we move all the metric gathering into that hook call. And this way, we just call it, and we will get all the metrics. So that's the better way of handling that. Okay. So what else can OpenTelemetry do? This is one of the coolest things that I found doing research for this presentation. There is a tool called trace test, and it acts like a receiver to the collector. So it accepts all the spans that your code generates, and it can do assertions on them. So let's imagine that we want to do end-to-end test of user registration. We start the registration, we send the information, and then we expect, for example, to have 6 insert queries to user, to company, to something, and we expect the email to be in the inside of the text of the query. So this is super useful because you can just connect it to your end-to-end framework and then expect some things in it. It doesn't have to be expectation about the text in the, for example, one of the attributes. It can be expectation also about the performance. So the whole end-to-end test needs to end below in shorter than, I don't know, 30 seconds. And the performance can be also done, the measuring can be also done on the span level. SQL commenter is a library that can add the trace information to your SQL queries. So it modifies the queries and it sends the information to the query and to the database. And then if you use, for example, slow log, you will get the trace ID for that particular query. So you can copy the trace ID, go back to your backend and UI, and for example, search for exactly which trace generated that one query. The upcoming thing for OpenTelemetry is a profile signal type. This is at the first look, it's similar to the span, but it's more like a XHProf. If you use XHProf, it measures every function call that you have in your code, and you can visualize that or do some other things. So OpenTelemetry is preparing similar thing for them. So the tools that when they release it and the vendors will add it to the tools, you will be able to do something similar that XHProf is doing with the all information, not the specific spans. We are almost done, I promise. So lesson learned from us. Telemetry data is only the beginning. So we started pushing everything to our vendor, but this gives you nothing. You need to define the alerts, you need to define the thresholds, and then act on that. Double check your vendor. In our case, we decided on one vendor. They said that they treat the OpenTelemetry data as first-class citizen. Unfortunately, it's not always that because some of the vendors that started before OpenTelemetry was introduced use their own ways of collecting data. Some of them do support OpenTelemetry, but it's not entire like a native support. There are some vendors that are OpenTelemetry first, and I do recommend them. And one like technical one, so auto instrumentation framework libraries from OpenTelemetry are using register shutdown function to push all the data after your code is done. So fast CGI finish request is a very good friend of yours because you can put it at the bottom of your code, and then FPM will tell the Nginx that, hey, I'm done, and then the metric sending will start. So you will shorten your request by a few milliseconds. Remember to send all metrics, and those are 2 configuration options from OpenTelemetry PHP framework. First is to send all the information. So in case of up-down counter, for example, the default configuration for OpenTelemetry, when you do +1 at the beginning of the query and then -1 at the end of the query, it will compute the difference and it will send 0 to the backend. And that's not that useful. If you put the delta in here, it will send all the values with the timestamps for them. And or the second setting will tell the metrics to send them always and not when the trace is enabled. That makes a huge difference. Another lesson that we learned is to sample our traces. So industry standard says that it should be under 5% of all of the traces. In our case, we sent everything with the error and 1% of other. Monitor your collectors. So the collector has the option to send metrics about itself to your backend. So enable that. It costs almost nothing, but it will allow you to create alerts. For example, when there is too much traffic on the collector level, too high memory usage, or stuff like that, or where the collector is dead, for example. And as I said before, remember to be careful with instrumenting the code. In our case, we enabled everything. We had everything, but it was not that useful. The more useful is, for example, enable only traces with error status. That way, you will know more about what happened. You don't need to know information about the successful ones. Well, maybe except for the slowest one. The code, if you want, the Docker Compose and everything, and README and all the tools are or will be in at this repository. Shameless plug, my employer is paying for this, so we are hiring backend developers, front-end developers, project managers, senior developers, staff developers, leaders, everyone.